So I'm Pierre Souchet, I'm working for Criteo. I'm leading what we call the discovery team, which is responsible for writing SDK for the whole company, as well as administering the deployment of all Consul agents on your large data centers. We've got around 40,000 Consul agents in 9 production data centers. And by administering Consul every day, we had to fix some issues regarding scalability, so we are also the first external contributors to Consul. And incidentally, I also write a kind of a clone of Consul template called Consul template RB that allows you to do some magic things I might show at the end of the presentation if I have time. So today, first I'm gonna explain a bit the context about the history of the introduction of Consul within Criteo. Then we'll go deep in the subject, explaining exactly what is inversion of control, what I mean with that. Then we will see a bit real-world examples that we are doing at Criteo. And finally, we'll explain how this way of dealing with infrastructure completely changed the way SRE team can work. So let's start with the history of Consul at Criteo. So Criteo is a large advertisement company. We are performing what is called RTB. For RT means real-time bidding. So it means that we have to answer very, very quickly to auctions. Otherwise, we lose the auction. So it's very critical for us to have good latency. So historically, Criteo is a bare metal shop. No cloud here. Just physical machines, the closest possible to the edge, and trying to be as fast as possible. The company did grow quite a lot by increasing the number of machines. Today we are around 40,000 machines in 9 production data centers. We've got around, I think, almost 4,000 kind of different services. And we are dealing with more than 3 million requests, HTTP requests per second daily. We can go further, for instance, during Black Friday, but that's the usual sound. All this data is sent to Kafka, where we are ingesting more than 8 million messages per second all the time. And in order to feed our big data Hadoop clusters, when we've got more than 180 petabytes of data. So it's clearly a big infrastructure. And so let's go back a few years ago. So a few years ago, Criteo was already embracing microservices. When I say microservices, I'm not talking about containers, I'm talking about simple applications doing one thing well. So simple applications were actually huge, but we had lots of them. So basically, when data was coming from the internet on the top of this image, it was going through a web app. This web app was using caches, Memcache, Couchbase, stuff like that, database, essentially Microsoft SQL servers, but we've got some others as well, and also performing a few calls to microservices. So huge microservices, but still. And of course, those apps were also sending logs to Kafka. It was not Kafka at that time, but doesn't matter. So in order to get the best latency we could get, we switched to service mesh. So everybody knows what is service mesh, right? So basically, there were no service mesh as infrastructure. It was service mesh developed as a library. So we did develop some code in order to trigger to ask to a database, oh, what are the microservices I can ask a question about? And it will give you the answer. Whenever the list of those microservices is changed, then the load balancing would change as well. So it means that we wanted to avoid as much as possible load balancers. Let's dig a bit into that. So the first part of the system was the F5 load balancer on the top. So this stuff was driven by a kind of magical Perl script interacting with our chef database and stuff like that. And this script has to be run every time we added or removed some machines. Of course, it was Perl, and it was complicated script. Sometimes it didn't work. Sometimes it was slow to refresh, and so on and so on. It caused quite a few issues, but still, it did work. So this was just to configure the F5 load balancer in order for the web app to be reached. For the second part, where we were doing client-side load balancing, or service mesh, then we had a kind of database where every time we added a server, database, a cache, or whatever, we added a line there. And our library were polling this database every 10 minutes or something like that, so they could get a fresh list of the services they wanted to target. There's something interesting there, because in both the LB F5 and this load balancing mechanism, while you know the list of machines, you still need to know whether those machines are up. So you implement some kind of health check in each of those systems. But of course, after some time, you forgot to do the health check, and lots of issues arise. And finally, in order to send our logs, to configure this stuff, we were simply using Chef. Chef is running every 30 minutes. So during 30 minutes, if you lost some logs, some log servers, then you're going to lose some logs. In the year after, we introduced Mesos. So you know Mesos, it's basically a system to deploy containers, to run containers. The big difference between our static system and Mesos is we can spawn a new application very quickly, in a few seconds. It means also that there are frequent changes. And the other point is we can have many, many services packed on a single machine. And of course, it's a completely different provisioning. So everything we add could not work. So we added something. We added a load balancer, HAProxy. It was the load balancer we chose. It was linked to Mesos. So every time a new service arrives or is destroyed within Mesos, the HAProxy load balancer notices it, and it's working. You can see directly on this picture that something is weird, because we did use service mesh to send data to our various services. So what happens when you want to migrate from a bare metal service into a container service? Then this service will be hidden behind the load balancer, and your service mesh library won't be able to detect the exact instances running. So it was a major pain for us. In a large-scale infrastructure, you cannot say, okay, let's scratch together, let's move to Kubernetes now, and everything's going to work. You have to do it gradually. So it was a real blocker for us. Furthermore, the load balancer also had health check and so on to detect whether there were a failure or something like that. So it started being very complicated. And furthermore, you had the other interesting aspect with containers is you want a more fine granular way of spawning new process. On a large machine, when you are alone, you can spawn a huge process with lots of memory, lots of CPU, and so on. In a container, you want to do something smaller. Why? Simply because it's more cost effective. So all of this was kind of working, but we had too many limitations. Provisioning time, database polling show its limit. The health check was a real issue. For services, both in container and machines, we had the same issues about load balancing this traffic. And finally, having a load balancer in front of Mesos caused an increase of latency, and we didn't want that. So it was time to move on. So we decided to move to Consul. So I'm not going to present Consul, but you still know it. The very interesting stuff for us was it is aware of having several data centers. It supports good semantics about services. I mean, semantics we did like. Provide real-time updates, provide DNS toolbox, and so on. So it's very, very effective to move from machines to services. So what we did was simply, okay, for all of our systems that are provisioning services, Hadoop, Chef, Criteo Deployer, an app we've written, Mesos, and so on and so on. We simply added service definitions and put all of this into Consul. At the same time, because of the health check issue I was talking about, we also added directly the health check into our service definition, meaning that we knew when a service was really up, and it gets us strong semantics about whether the service is supposed to is healthy or not. And we also added a few tags such as, oh, this service is speaking HTTP. Step 2 was, oh, we have to re-implement all of our libraries, our load balancing service mesh libraries. So we did that. So we had a library for HTTP load balancing. So instead of using the database, we start using Consul. So we watch everything, so we get notified when a service goes up or goes down, which is very important because in Mesos, your application can start in a few seconds. It's not a few hours of delay to provision a new machine. Database, the same thing, Kafka, and the new SQL part. For the load balancer, we did choose not to create as-a-service stuff, but simply to watch what is going on into Consul. And whenever a service is marked as HTTP, let's take it, let's get its definition. So the service will notify Consul that something is changing. Consul will notify a third-party application. We call it VAS, like a VIP as a service. And the VIP as a service system will provision the new reverse proxy configuration in order to make it work. But it can go further. It can, for instance, create a DNS name, TLS certificate, and so on and so on. Whenever instances are not healthy anymore or are added or removed, of course, the VIP is modified. And the interesting thing as well, very interesting, is whenever the last instance of your service is dying, the VAS configuration is removed, meaning that you lose your VIP once you don't have any instance. That's very interesting because, you know, in computing science, we love adding stuff, but cleaning the mess is sometimes harder. The very interesting property of that is, since it's not yet another API to call, that no one will call this API once the product dies. However, if the service is simply not there, everything is cleaned up. So that's very interesting. Okay, it was hard. It was really, really hard. The issue we had several performance issues at our scale with Consul, so we had to put lots of optimization in order to make it work. Our first big issue was when we started to implement this stuff, it was saturating the network card just to look at all the changes in the cluster. So we went around 800 megabytes per second just to watch the changes. So we had to develop strategies. So we developed a patch into Consul to have a cleaner way of notifying the watchers. And now we are around 12 kilobytes per second to do the same. So that's quite a huge gain. We had issues with DNS as well because we had pretty large services with several hundreds of instances per service. So we had lots of issues with DNS, truncation, stuff like that. Another big issue we had was everybody was watching with Consul is known to be consistent by default. So if you don't say, I'm not interested into being very consistent, then every time you watch, you hit only the leader. So we added a feature in Consul in order to say, whenever the user does not specify it, you're not gonna ask a consistent read. Meaning that the Consul server leader has not to answer to you, it can be any of the followers. So you can scale Consul horizontally, which is very important as well. And finally, we found that we were a bit limited with just this way of saying, of having a name of our service. So we wanted to add some new data to this service to help the VAS system to take decisions. So we added service metadata, which is available starting from Consul 1.1. So it allows you to put arbitrary key value for all your service definitions. And at the same time, since we were dealing with load balancing, we found interesting that, for instance, the DNS interface And all our system of load balancing would standardize a way to apply weights for our load balancing stuff. Why? Because as I said, for the containers are quite smaller than full service instance. So the good news is all of those change. It took quite some time to make it working well with Consul, but all of those problems are solved now. So we learned quite a few things about that. The first is users, developers, project manager or whatever, they love their service. They don't care about yours. So meaning that it's a shame that every time I enter a new company, I have to know that I have to modify 10 Git repositories to get my service working. I just want to put my data and everything reacts to this. It means that pushing the configuration close to the service is probably a good idea. Another thing is users want predictability. It was very hard because we had lots of performance issues at that time, but still what we did was pushing UIs that give users all the information they needed to investigate by themselves when there were an issue. So it means that we were free to do something else, such as patching, adding some optimization, and so on and so on. So users want predictability, and when it fails, because it always fails sometimes, they want to be able to inspect what is going on. And another very interesting stuff is people love business semantics. As a user, I want to expose a web API. What I know is I want that my API.criteo.com is seen on the internet by people. I don't care about knowing everything about TLS. I don't care about knowing anything about DNS. I don't care about all the crap of the infrastructure. I just want this. So instead of configuring tools, instead of saying, oh, I want this TLS something option in my DNS or reverse proxy or whatever, just ask them to put the data they want. So they just want a DNS name, basically. And finally, they want it fast and magic. Everybody loves API, but the problem with API is someone has to call them. And that's especially the cleanup problem that comes to surface now. So can we go further than that? Yeah, of course. So what is inversion of control? So for those doing some Java Spring stuff a long time ago, they remember, inversion of control must be something like that, but it's not dependency injection. It's broader than that. It's about decoupling systems using a framework. This framework is going to be Consul. So the idea is we want to provide, services will provide some semantics of what they need, and someone else will take care of it. So it's really about decoupling producer and consumer. So Consul exposes lots of stuff. It allows you to list, using APIs, to list all the services, to filter the services using tags, to get notification in real time, and to provide configuration settings via using the KV or the service metadata we added. So it's very good. So let's use it. So when we want to create a new consumer for this whole infrastructure, we're going to just search into those semantics using tags. No, sorry. The service will provide tags in order to be filtered easily. It will provide configuration hits with business semantics about what he wants. And some other tools will observe, react, and provision. So it means like Consul is a database. And a database for which you get notification on every change. That's quite interesting. So how does it work? There are three real-world applications we are using at Criteo. So the VAS, I already explained you. Auto alerts, that's a stuff that scan all the services of Criteo and create automatic alerts. So you just say, I want 30% of availability, otherwise page me even at night. It's going to work like this. So we've got a 100% coverage of all the services in Criteo with this kind of stuff, very easily. without people noticing. The only thing they have to do is they can tune the parameter at which they will be waking up. That's all. We've got a Swagger catalog. So a Swagger catalog, you might know Swagger. Swagger is a popular way of explaining how you can call JSON REST API. So we've got an application, Swagger catalog app, which is on the right. So this application basically lists all the services of all of our data centers, find those tagged with Swagger, and if you look carefully, you will see that a few of the keys here start with Swagger something. One is going to say, oh, I need authentication to be called using the SSO. And one other are about how you're going to present your application into your Swagger catalog app. And here, on the right side, you see the application displaying simply your Swagger catalog. And what's even more interesting is, since it is linked to Consul, you can call it directly. So you've got an automatic catalog for auto-documenting all your REST services using Swagger, and you can call it directly. You can try the examples. So it's very fun. Another example, here on this service, you see that many start with alert something. So we can take decision if those values are missing. For instance, I can say, oh, by default, it will be if the application is less than 30% availability, page the guy. But everybody in the company is able to tune this to get their specific value. They can say, oh, I want to be paged on Slack during the day. I want to be paged for another team will be paged during the night if it fails, and so on and so on. So it's very efficient. With this, we've created 4,000 alerts, more than 4,000 alerts for all Criteo. So we've got 100% coverage. Who has 100% coverage on this service here? That's really, really interesting. Ah, yeah, Datadog, cheater. So why is Meta so cool? That's simply because the people who publish these services, they can edit this stuff. So they can directly put the information they want. So we just have to namespace it a bit, but it's very easy. Another point is all our UIs show directly this information. So it means that whenever you have an issue with a network issue, for instance, you have at the same place the information about the service and about all the configurations that led to the network interface or something like that. So it's very, very interesting. But we are not doing this only for, of course, for configuration. We're also using it for adding metadata. For instance, we add version, the team, the ownership, and so on and so on. It's very useful because this can be used, for instance, to track progressive deployment. This can be used to track code that has not been deployed for a too long time, and so on and so on. So it gives really, all of this data can be reused by several tools very, very easily. And finally, the biggest advantage is it's automatically cleaned up, meaning that when the service disappears, no one has to take care about removing the old configuration in Centurion or whatever. So the consumers of this metadata can be either opt-in, for instance, VAS. I'm speaking HTTP, so it's opt-in stuff, or opt-out. We've got, for instance, some chaos monkey killing random instance on our services, but you can say, ah, no, this service, no, sorry. So every service we can put there can choose its own way of being opt-in or opt-out. And it's very, very easy to develop. Another point is we are combining the node metadata with the service metadata, meaning that when you get the metrics, for instance, or when those tools are using this metadata, they can use the node metadata or the service metadata. So the service metadata is going to say, for instance, oh, my application is running version X. The node metadata will say, oh, my operating system, by the way, is Windows, this version, and I'm on this rack, and so on and so on. What is very interesting is Then, for instance, if you are using Prometheus, all the metrics linked to this data will have those tags. So for instance, when your application starts misbehaving, you can see, that's fun because only the instance of this application running on this rack are suffering an outage. Why? Must be network. It's always network. Anyway. So the other good news is all this metadata we are producing are reusable by many people. Version can be used for the guy who is tracking the old version. Version can be used to do progressive deployment, this kind of stuff. So the more data you are adding, the more ease you have to create new services on top of services. So many people in the Consul community are using the KV for that. I would say, is the KV the real place to do that? No, I don't think so. Why? Because first there's a problem of cardinality. When you've got a web application, this web application can run Nginx, Apache, whatever the server you want. But what is interesting here is they don't have at all the same kind of identity. They can have different health check, they can have different metrics, and so on and so on. So when you tend to put everything in the KV, you will forget about this. Version is another issue. For instance, imagine you have a version, a specific version of your application. At version 1, the health check is called HC, and version 2, the health check is called health check, or whatever. What I mean is, a service is not a monolith. It's a combination of several service instances, and each of them has its own metadata. When you do put things in the KV, most of the time you forget about this. So it means that probably you will get it wrong. The other point is, within the KV, you have to clean up stuff. With service metadata, you don't. Finally, it's very cool that the people don't have to know yet another path, yet another Git repository where to put the KV data. They just put it in their service, so it's close to the service, so it's very efficient. The only downside of that is when you are a consumer of this metadata, you have to work a bit more. Because for a given service, you don't have one single version. You can have 2, 3, 10, whatever. And all the data within can be very different. For instance, if I put alerting, okay, in the metadata, I'm going to say, I want to alert team X, all right? But for the next deployment, we are changing team X to team Y. What is going to do the alert manager about that? What kind of decision he has to make? So it's a bit more work on the producer side, but on the consumer side, but it's definitely doable. So the other idea is, let's put semantics. Don't use tool-oriented stuff. You just say, I want my alert ratio to be 0.5. That's fine. But putting some tool-specific stuff, such as Prometheus alerting something or whatever, is probably not a good idea. Why? Simply because, first, the users don't have to know anything about the tools you are using. And secondly, last time we changed our monitoring system, it took us 2 years. Because we had thousands of lines configuring our old system. So moving to the new one just took 2 years. If you just stay on business semantics, then moving to another system is trivial. You just have business needs. So a few real-world examples. All of our, we've got automatic methoring and alerting for all of our app. So for free, when you start an application, you've got the graph of availability for it with tags about the version, the rack, the whatever. So it's very, very efficient. So we've got the VAS, so I already explained a bit, but in 1 minute, you start a service, it's available on the internet. You remove a service, it disappears. We've got also a service scanner, which is very fun. Basically what it does is, in a large company such as ours, we've got lots of teams, and people like renaming teams. So it means that most of the time we've got offline services. Who is handling this application? You can do this in pre-submit Git hooks, for instance. The downside of that is if your app is staying 2 years in production, the team doesn't exist anymore. Having such system means that the day the team disappears from the LDAP, you can be notified, oh, it needs ownership. That's very interesting. It can also detect that, for instance, here we can see that it's running a very old version of more than 200 days, old version, so we have to update it. So all of this can be automatic. The other cool thing about watching this is you don't need to be on the production to start developing those tools. You can take on your laptop. You need 12 kilobytes of bandwidth to do it, so it's not big. And you can watch the whole stuff and develop your own. So it really enforces innovations. We've got also another tool which is called Consul UI, which is available in open source. And most specifically, it offers a very, very nice feature which is called Consul Timeline. It shows all the changes in your cluster in real time and logged for 1 week, for instance. It means that when I was talking about people love predictability, they also would like to be able to inspect everything what is going on. So with this tool, they can click on their service name and they're going to see all the services are up, down, and so on and so on. Everything is open source there. You can use it tomorrow. And it's scaling up to hundreds of users because it's just basically Nginx served static content, but updated in live. And much more. We've got Swagger browser, Chaos Monkey. We've got some system to track the resource, latency monitoring between machines, security scanner, and so on and so on. So security scanner, for instance, when a new service starts, then the security scanner, instead of waiting to scan the 4,000 machine, can directly target this service and say, there's a new service speaking HTTP, maybe I can see if I can find something. Interesting. Okay, and now, how IOC can change infrastructure. First, it removes the configuration from hidden place. You don't have to know everything about all the Git repositories within your infrastructure to make things work. You just have to configure your service and everything is going to work. For engineers, it's really, really great. So everything is transparent. We provide UIs, so everything can see the configuration. So there's no doubt about, oh yeah, but I forgot to push this pipeline in Jenkins. No, no, no. Everything is automatic. Everything is instant. So you can get real introspection about what is going on in your data center. So information is where it really needs to be in the service itself. It also is the onboarding of the newcomers. I don't have to learn you the 10 Git repositories important to deploy one single app. Cleanup is not a hard problem anymore. In every company I've been, cleanup was always a mess. Why is this line in this Git repository? It must be something old. Was not. Okay. It's very, very hard. And this removes completely this problem anymore. So it's very cool. And it helps innovating because there's a real decoupling between the tools and the semantics. So anybody can start a new project on their laptop to replace the VIP as a service stuff on our side. You can start a new, and we provide also some templating systems, a bit more evolved than Consul templates, so you can get real strong performance, just generate configuration files, and do it that way. And finally, the very interesting stuff to me as well is semantics are probably better than YAML files. So I have 50 seconds to do a demo. So I'm going to try. Yesterday I went to the Terraform talk, and they talk about pushing a price on evaluating the price of your infrastructure. So I'm going to do the same, but with this mechanism. So basically, I'm going to launch the Consul template RB, so it's the open source stuff that is doing the GUI and most of the stuff we are doing. And I've developed a little script this morning that here are the kind of machines we have in our data center, explained as node metadata. So I'm going to scan all the instances of a real-world data center in Paris and see what happens. So for each of these instances, I put a price, and I want to compute the price in Hashi dollars to get an overview of what costs my infrastructure. So let's do this. Okay, it's done. So it's ready. So now let's see the data. Okay, we've got three. So I watch a single service in Paris. I'm going to show you this service. That's the kind of service we are watching. Oh, this is not on the right data center, but anyway. So, okay. So now, how it helps innovating. Look, here is at the top the name of service I'm looking up. Okay. So now the first problem I have is I'm doing this on one single DC. It would be cool if I could do it on every DC. So let's do it. Data centers dot each do DC. So I'm going to do the same stuff, but accumulating the number of machines for each data center. So I just need to put something like this to list the service per DC. Okay, so as you see, everything is reloaded directly. Okay, it's working. So now I've listed all the machines and computed a price for all the data centers of my infrastructure. I've done it in a script that is something like 20 lines. Okay, but let's go even further. I put a regex for the name of my service, all right? So I'm going to do this. So I'm going to compute the price of all the web servers of Criteo. Okay, I've got my price yes, it's ready. So now I've got 7,000 machines just for the web, and I've got my new computed price. And of course, I can change the value, and it's going to change directly the price. Ah, nice. So if you want to develop those tools, it's fairly easy. This tool can send a SIGUP, or you are a tool outputting this to a web API or something like that. You can have real information. We even see that there's a flavor of my machines that I didn't took into account, so it tells me, I don't know how to compute the price for this one. So it's very trivial to add. And then I'm done. Oops. Okay, I must have a new price, I think. Anyway, well, it was a quick demo. So thank you very much. And I just show you a last time which could interest you, which is the, oh no, not the version, the timeline. Showing everything in the real time and in what is happening on your Consul cluster. So in real time, you have why a service is down, up, and so on, and you can filter with service, and so on, and so on. Thank you very much. I hope it gave you some ideas in order to really change the way the SRE can work in a modern organization. Thank you.